Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, let us try to explore the concept of tables in Faust. Okay. So already in our previous video, we discussed several concepts related to Kafka stream processing using Faust framework. If you want to know that detailed explanations, you can check the link given in the description box, and I will request you to have that fundamental concepts because those concepts will surely help you to understand today's topic in a much better way. Okay. So let's try to understand what is tables in Faust. So a table is a distributed in-memory dictionary backed by a Kafka changelog topic used for persistence and fault tolerance. Okay. There are multiple terms used in this definition. Let us try to decode them one by one. As of now, you can think a table is a simple dictionary which is distributed and in-memory. Like how we work with Python dictionary. Think like that way. A table is a in-memory dictionary, right? With this concept, let us try to implement a program. Let us try to understand how to create a table, how to insert a data in a table. Let's print the table and let's see how it is getting displayed. Then we will try to decode the further definitions. Okay, right? So here I have written a small piece of code. Let's try to understand one by one. So here we are first importing Faust, and here we are creating an application, giving the application name as demo streaming and pointing to our broker URL which is running in localhost 9092 port. Okay. Then here we are creating a complex type. Class name is greeting, and first record should have two key value pair of JSON data. One is name, one is age. Name can be string type, age can be integer type. Okay, right? Now here we are creating our input topic object at line number 9. The input topic name is suppose hello world, from where the input stream our Faust application will be continuously consuming. Okay, and the value type what our input stream will be sending, that is this kind of complex type. That is one JSON data it will be sending which is having name and age, these two key value pair, as simple as that. Okay. Now to create a table in Faust application, you have to use app.table. Okay. Then here you have to give the table name. The table name I have given major count. And then just now I explained, right, that Faust table is nothing but a dictionary. So a dictionary will be having a key and a value. So key I am giving the data type as string. The value part I am giving as string. And then here partition, I want only one partition as of now because this is just a starting discussion on Kafka tables. In our upcoming videos we will consider partitions and all. And the default value it should be taking as int. Okay. So this is the definition we have given. Obviously the data types you can change based on your requirement. Now let's go to the next step. Here what we are doing here in this block. This is like what we discussed in our previous video also. Using decorator, we are defining that from this input topic the data should be consumed. And here we are defining our stream processor. Here we are iterating using the for loop. This for message in stream. This line is acting like a consumer from our input stream. And then the message data, whatever will be coming from input stream, as per this particular flow, it will be having one name and one age, these two key, right? So that age key, if it is greater than 30, then only we will insert that data point to our this table, aged table. Okay, right? So here we are applying a filter condition that if age is greater than 30, then we are inserting the data in this table. Now how to insert the data in a Faust table? It is same like how we insert data in a Python dictionary, right? That is age table. Then here we are defining the key name, then equal to value name, as simple as that. Okay. And then to understand how the data is getting stored, here we are printing that table in console. So to print in console, we are using this method. And then we are giving the title that whatever will be printed in the logs, that should be having this particular title. Okay. So I hope you understood this. There are some very important points while working with table, while trying to insert data or mutate the table, then you need to take care of very seriously. That is, you cannot modify a table outside stream operation. Okay. This means that you can only mutate a table from within an async for event in stream block. Okay. What I mean to say, if you see this particular application at line number 17, we are mutating the table. We are inserting data or updating data in the dictionary, right? So this operation is only allowed within our stream processing. So if you see here at line number 15, we are starting our stream processing using the for loop, right? within that we are mutating the table, that is perfectly fine. But you cannot do this kind of mutation outside stream processing. Maybe at line number 12, you cannot write within the table you are inserting some data point for some key value pair. So it is only possible within the stream processing. So that is very important point. And this particular method, as I told you, that to draw the table in terminal, we are using this with the title. Okay. So let's see by running the application how the in-memory dictionary will look like in table format. Okay. So here what I will do, I will quickly copy this particular code just now what I discussed and I will paste that here. Okay. Just only if age is greater than 30, we are inserting that data in our in-memory dictionary or Faust table. So what we need to do to start the first application? As a first step, we need to start the zookeeper, we need to start the broker, we need to create the input topic, and then we can start our producer, and then we can observe in the table, right? So let's do all those steps one by one. So here first I will start our zookeeper, and then here I will start our broker in a new terminal, and then here I will create a Kafka topic. So the topic what we are creating having name hello world. Why? Because if you see in this particular first application, the topic from which the input stream will be consumed, that is having the name hello world, right? You can give any name as per your wish. I just opened another new terminal and here we are creating this topic. Okay, I hope up to this it is very simple. Now to produce data in this topic, we can start Kafka console producer.bat file. Bat file because we are running in Windows. If you are running in Unix or Linux machine, you can use .sh code also, not a problem. And here we have started our console producer. Okay. Now in a new terminal, let me start the first application. So to start the first application, what we did earlier, that same command we are going to use. Okay. So here I started this. Let it give some time. So see here worker is ready. Now what I will do, I will first publish a data point with name and age, because as per the definition here the key value pair name and age should be there, right? So here name as maybe I can give A, and then here age maybe I can give 20. Okay, I will hit an enter. So if you see here that age is not greater than 30, so the data will be not coming in our Faust table. So here if you see in the console what it is printed, aged table is the title. Why? Because if you see when we try to print the table, we have given the title as aged table. So that it is printing key value, it is throwing empty, because the data point what we enter, that should not be coming in the Faust table as per our definition. Okay. Now here what I will do, I will give the name as B. Suppose the employee B is having age 35. Okay. I will just hit an enter. Now ideally this data point should be going to our Faust table. See here how beautifully this key value pair containing the employee name and the family. Okay, right? So I hope you are getting it. It is just a dictionary which is in table format, and that one we can mute it. Okay, right? And then maybe I can pass, for example, C. Okay, and then here the age is suppose 40, and then here I can pass D. Suppose age is 25, and then let me pass one more data point, E. Suppose age is 65. Okay, so what two new records we should be seeing? One is C and one is E. D is not allowed because D's age is less than 30. Okay, so overall earlier B was there, along with that in that same table C should be appended as a new key value pair and E should be appended as a new key value pair. So B, C, E. Okay, let's see. If you see here, B, C, E are coming. If you see the complete log, initially what happened? B came, then B, C came, and then here there was no change, and now B, C, E came. Okay, so as and when the conditions are getting satisfied, whatever filter condition we have written in our code, based on that in the table the data is getting inserted, and then here it is updating and then printing in the console. Okay, so this is a bounded table. If you see, it is not like stream. In our Kafka stream, if you see here, when we are iterating, the stream is unbounded. As and when data is coming, the data is continuously flowing like, and we are consuming the input stream. So stream is unbounded, but the table is bounded. And another point is stream is basically immutable. You cannot modify any object of stream. You can just read the data and do some operation and write in other Kafka topic. All these things you can do, but actual stream you cannot mute it, right? But the table, any key value pair you can mute it, just like what we do in our dictionary. Okay, so these are the major difference between stream and the table. Stream is unbounded and immutable, where table is bounded and mutable. But the similarity is both stream and table are somehow coming from topic only. That is, it is nothing but both are wrapper on top of our Kafka topic. The stream is basically consuming all the input stream from our Kafka topic, and then after processing we are writing that some part of data maybe in a table, that snapshot we are displaying. Okay, so ultimately both are coming from a topic, but the only difference is stream is immutable and unbounded, tables are bounded and mutable. Okay, it is just like in-memory dictionary. Okay, I hope you are easily getting this. Now what I will do, I will stop the first application. Okay, right? So I hope this particular funda is clear to you. Now let's see another application. So this is a very popular application in our big data domain, that is frequency counting. Okay, you can think the situation like this way. There is a input topic where sentences are continuously coming. Now we need to calculate which word is appearing how many times in all the sentences since beginning. Okay, suppose that is the requirement. So we can write this piece of code. It is very simple. The first two lines self-explanatory, right? Now the third line, here we are creating the input topic. Okay, value type is string type. That is fine because input data will be sentence. So we are not using any complex type. Rather we are using string type only, and raw serializer we are using. Now here in the table, if you see, the key we are keeping as string. Okay, that is the word will be basically the key. Okay, and in the value part we want to basically keep the frequency, that which word appeared how many times. So that is integer type. So here I am keeping value part as int, and then partitioner and default also I am keeping as int. Okay, so when we are keeping value part as int and default also int, so by default in the first table, if suppose for a particular key the value part is not yet added, it will be considered as 0. Okay, because default we are configuring as int. Now here this part is the main place where how we are processing the stream, that matters. So input sentence will be coming. That sentence first we are splitting based on space. So message.split, that list I will be storing in data part. So whenever a sentence will be coming, that sentence will be splitted based on space. It will be generating a list. In that list I am iterating, and each word I am picking up, and that word if it is available in the dictionary, for that word the frequency I am increasing by 1. And if it is not available, then by default the value will be taking as 1. As simple as that. This is a normal programming style, how we increase the value for a key in a dictionary, right? So that same process we have followed here. Okay, and then here we are printing the table, as simple as that. So let's see this word count example also. So here I have written the code, and then here what I will do, I will delete this, I'll paste that here. Maybe for difference purpose, here let me give some different application name, and then here hello world 2 maybe let me give, and here word count let me give the name, and here count to the. Okay, so here I need certain changes. That is, number one is I need to create the application or the topic, right? So that topic I'll be creating. I'll terminate the console producer, and here I will create the topic, okay, with this name. Hello world 2, okay, and the topic got created. That's fine, and pretty much it looks good. So I'll save this, and here I will start our console producer, hello world 2. Okay, so here we'll be producing some sentences. We will see whether for different sentence the word count it is showing or not. So here I will start the first application. So here worker is ready. Now here I can give first sentence as hello world. Okay, so see, hello is appearing one time, world is appearing one time. Okay, now here I can give hello Kafka. Okay, so now what should happen? Totally hello will appear 2 times, right? So in this first topic, the value corresponding to key hello should be increased to 2. World is anyway 1 because in this sentence world is not available, and Kafka is a new word what we are adding. So here there should be a new row coming in this table which will be showing the key as Kafka, the value as 1. Let's run it. Okay, let's go to our first application and see Kafka, it is showing 1. Okay, so here let me write Kafka is very popular hello world. Okay, so like that I have written. So as per this sentence, Kafka coming 1, already it came earlier 1, so Kafka frequency should be increased to 2. Is a new word, its frequency will be 1. Very popular, these two also new word, its frequency should be 1. Hello, it is coming again. So earlier it came 2 times, now it is 3rd time. So hello's frequency should be 3 and world's frequency should be increased to 2. So world will be coming here and already it came here. Okay, so I will run that and see hello's frequency increased to 3, world is 2, Kafka 2, is very popular is 1. Okay, like that. And not only this, suppose your first application fails due to any reason, then the backend is configured such a way that when you will restart the application, it will bring the Kafka table state same as like this, that is before failure whatever state was there, to that state only it will be taking. Okay, let me show you that also. So here I am intentionally terminating the first application. Now let me publish some more data. Hi world. Okay, so hi is a new key we are passing and world is an existing key. So already world's frequency we have seen 2. Now it should be increased to 3 when the first application will again be starting, and hi is a new word, so its frequency should be 1. Okay, so here we have entered and then hi there. Okay, so when we are writing this, high's frequency should be 2 because 2 times it is coming, there is coming first time, so its frequency should be 1. Like that, here we publish 2 data points when our first application is down. Now let's start the first application. So what will happen, that earlier its state was like this. Before termination, the state was like this. So this state it should be taking and then it should be updating the key value pairs for which the data points already came in the input stream, which the first application has not consumed because it was down that time, right? So let's see whether it is doing that activity or not. So see the beauty here. Hello world, Kafka is very popular. All these things earlier also there, now also available as it is. Before first application failure, what state was there, it has brought to that state. Not only that, here hi world and hi there, these two I published newly. So hi word came 2 times, their word is coming 1 time, and world was increased to 1 more value, that is its frequency is now 3. That is the beauty of fault tolerance in this Kafka Faust table. Okay, and you can do statistical operation and lot of operation on this table. I will come to those topics in our near future, that how we can make use of this in-memory dictionary. But I hope you understood the definition now. That is, table is distributed in-memory dictionary backed by a Kafka changelog topic used for persistence and fault tolerance. Okay, so what is changelog topic? It is nothing but a topic which is created by our first application in the backend. Let me show you that. If I go to Kafka logs, if I go to server logs, here you will see along with consumer offset 0 to 49, here some more metadata topics are there. Okay, so if you see here, word count changelog, major count changelog. So word count changelog, word count is nothing but the table name which we used just now in the word count example, and major count was the table name which we used in our earlier first table. If you see this code in this first application, here we have given the table name as major count, and currently in this word count example we are giving the table name as word count. So whatever tables we will be creating, for that in the back end different changelog topics will be created, okay, which will maintain the state up to what it got consumed, etc, all the metadata information. Now if suppose your first application is failing, now when you will restart, it will again consume from changelog, and that way it will become fault tolerant. Okay, so we can replay the changelog upon network failure or node restart, allowing us to rebuild the state of the table as it was before the fault. Just now we saw that, right? That is what state in our table or in-memory dictionary it was having before the failure. After recovery, it brought back that state. So how it brought back that state? that brought back happened due to this changelog property, right? I hope you understood these two very important points. Obviously, I'll be sharing the documentation link in the description box also, from where you can explore much more concepts related to this Kafka tables and its applications, right? And another important point with respect to interview is what is the difference between stream and table. So already I discussed streams are unbounded and immutable, tables are bounded and mutable, but the similarity is both are wrapper on top of Kafka topic, right? I hope you understood this. All the codes I'll be providing in the description box or in the comment section. Play with it, try to understand what is happening in what step. You will be getting much more feeling out of it then, right? And you will enjoy it much more also. This is all for this video. If you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.